All right, for 2.2, we're doing graphs of functions, and we are going to analyze and graph piecewise functions, and then we're going to select appropriate viewing windows on the graphing calculator, and then if you're using the Desmos test mode, we're going to do that too. Okay, so for your first example, we need to graph the functions in each of those given rectangles. Okay, so if you have your graphing calculator, you can go ahead and type that in to your y equals. Okay, so it says graph the function in each of the given graphing rectangles. And then we are going to select the one that produces the most appropriate graph of the function. So all of those choices are given in x by y coordinates. So this is going to be your x values. This is going to give you your y values. Okay, so when you are typing it in, you're going to do x to the fourth minus 2x squared plus 20. Okay, and if you're in Desmos, you're going to be using kind of the same type of keys there. And then we're going to go to the window. All right, and then your window is negative 10 to 10, and then negative 10 to 10, and then the scales are just what do you want it to go by, so by ones is fine. And then when you graph it here, you don't see anything, okay? It's just a blank graph. So for each one of your choices, you're going to show your work just by saying what happens. So for here, you can just say no graph, and then I'm just putting like the blank scale on it. Okay, and then I want you guys to go on to the next one. And then if you are using Desmos, you're going to click on your apps, and then it's this one. So you're going to have to use your test mode. All right, and then we are going to use the calculator. We go to start test. And then you can just use y equals, and then it's x to the fourth power, arrow down, minus 2x squared, so to the second power, plus 20. Okay, and then to change your scale in decimals, we're going to use this little wrench here, and then it says x-axis. So it already has negative 10 to 10, but your y-axis does not. So we're gonna go down to the y. And we're just going to make that -10 to 10. Okay, so again, you see what we see, right? A blank screen. Then for the next one, your window is -5 to 5. And if you're using your graphing calculator, you're just going back to your window and then 0 to 15. Okay, so again, do I see any of the curve on my window? Did you see anything on your window there? No. Let me change this to -5 to 5. All right, so there was no graph visible there, but it did change, right? So we had a scale there. Okay, and then again, we'll change the window. So -2 to 2, 18 to 28. And all right, we have a curve there. So just draw like a rough sketch of that curve. And then you're going to choose which one gives you the best picture. Okay, and your little graphs for each one is going to represent what you have. All right, so here you can see you had kind of like a stretched out W there. And then -100 to 100. And this kind of looks like the bottom of a canoe here. Okay, so which one did you guys think has the best looking shape? C. Okay, because you can actually see your curves in that. Okay, so for those, again, you can just write A and then the no graph, B, your no graph, what that looks like, and then the shape for each of those, and then you can circle in your part C is what you want there. Okay? All right, we're going to take a break from the graphing calculator. We are going to use it again, but now we are going to sketch piecewise functions. Okay, and this book says sketch. You are going to actually graph it. Okay, it's not a rough sketch. You're actually going to be drawing it. And when you're doing this, I think it's helpful for you to identify the type of function. So with this value here, this is f of x is equal to 1, which is like y equals 1, and y equals x plus 1. So think about what the graph will look like. If it's equal to a constant, then your graph is just going to be a horizontal line. Okay, if it's a linear function, it's either going up or down from left to right. Because the slope is positive, I know it will be going up from left to right. So this gives me an idea of what the pieces of those graphs are going to look like. So now we are going to make a table. You want to include points in each interval, and we're going to label them as an opened or closed circle. You need to make sure that you include your key values here. Okay, so the key values are given by these intervals. If x is less than or equal to 1, if x is greater than 1, okay, so our first piece of the graph is f of x equals 1. Our second is f of x equals x plus 1. I'm just using f of x because that's what it's called. It's the same thing as y as your output. And then we're going to make a little table for each one. Okay, on your table, you are going to put your key values. So if you have x is less than or equal to 1, 1 is your key value that you have to put on your table. For this one, the key value is also 1. Okay, and sometimes that bothers people because it says x is greater than a 1. Okay, and they try to start with 2, but we're going to graph it, and then I'm going to show you why that would not be correct. Okay, so now that you have your key values from the interval, you can tell if it's an open or closed circle based on the symbol. So it's closed if it's equal to, so I generally just write that here, like it's a closed circle. That way I don't have to like keep going back and forth. And then this is an open circle. So then I can graph it right from my table here. Okay, and then if x is less than or equal to 1, you can pick any values that are less than 1 now. I just choose 0 and negative 1. And then here I want values that are greater than 1, so I'm going to pick 2 and 3. And then I usually just do a couple for each. Now, yesterday we talked about if you have a constant and you go to plug this in, your answer is just the constant. So if you plug in 1, there's nowhere to plug it in, it's just 1. If you plug in 0, you get 1. If you plug in negative 1, you get 1. Okay, and this part of the table, if I plug in 1 for x, 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. And now I can graph this. When you are graphing, just keep in mind in a piecewise function, the lines are never going to overlap each other. They're never going to crisscross. Okay, the lines never overlap. And that's because they're on different intervals. Okay, they're never going to be on the same interval. Okay, it can only be one equation for these values of x, one equation for these values of x. The only thing that would possibly overlap is an open and a closed circle, and we'll investigate that in the next case. All right, so let's go ahead and graph. When you are graphing this closed circle at 1, 1, okay, you can make that a little bit larger to show it's a closed circle, but these are just going to be small points. So it's 0, 1, it's negative 1, 1, and really this is a straight horizontal line, so you can just have it going to the left. Okay, so you don't have to put other large points on there. So in the second one, your open circle is at 1, 2. So over 1, up 2. Again, this is the only open circle. The rest of these are just small points. So 2, 1, 2, 3. At 3, I'm at 4. Really, my next one would be here. So I'm going to connect those. Okay, this is your piecewise function. Okay, so I said I was going to talk to you about why this bothers people. So if it's x is greater than 1, people don't like that because they're like, but it doesn't include 1. Well, if you just started at 2, you just started here, you would be missing all of these points in between. So it's not just whole numbers. This part is continuous here. Okay, so you have to plug in the 1 so you can find the value right next to it that's going to continue on this interval. Okay, so you can't just skip to the next whole numbers because you're missing all those decimals in between. Okay. All right, so for part B, we're going to try another piecewise, but this time we have 3 pieces. Okay, so your key values are always given here. So 0, 0, and 2, and 2. Okay, I always do the first step where I identify what type of line it is. So this is linear, so I know this part is going to be going up from left to right. If it's x squared, it's a quadratic, and so we know a quadratic has what shape? A parabola. Is this one going to open up or down? Down, because what's in front is the negative. So you're going to have part of this parabola. You might not have the full U shape, but you do have to make sure you connect with a curve. Now this one is linear also, but the slope is a negative, and that's how I know it's going to be going down from left to right. Okay. The first step is not mandatory for you to do that. I just want you to understand like how we know what the graph looks like, how we're going to know to curve this. And then we're going to set up our 3 tables. Okay, so you have 3 different equations here. We have f of x equals x plus 4. F of x equals 4 minus x squared. And f of x equals negative x plus 4. Okay, so again, we're just doing 3 little tables here based on our key values. Okay, so 0 is a key value. Sometimes I'll just put like a little star, and then because of the equal to, it's going to be closed. This one has to have 0 and 2. Okay, 0 does not have an equal to, so it's going to be open. 2 is going to be closed because it does have an equal to. And here, your 2 is going to be open. Okay, so we're going to follow the interval. So if it's less than or equal to 0, then I would plug in like -1 and -2. Okay, so when I plug in 0, 0 plus 4 is 4, -1 plus 4 is 3, -2 plus 4 is 2. Okay, and this one, I am going to plug in the 1 in the middle as well. If I plug in 0, 4 minus 0 is 4, 4 minus 1 squared is 3, 4 minus 2 squared is 0. So we're just plugging those in using mental math. Okay, and then anything bigger than 2, so I could choose 3 and 4. So if I plug in 2, this is -2 plus 4, which is 2. -3 plus 4 is 1. -4 plus 4 is 0. Okay, now sometimes you will get a closed circle and an open circle that overlap. Okay, so we're going to write just a special note for that. And if you don't have room underneath your tables, you can just put it up here. Okay, so if an open and a closed circle overlap, okay, it will stay closed. The closed wins. Okay, it will stay closed. Okay, so if an open circle and a closed circle overlap, it will stay closed. And then sometimes what I'll write is no targets because people will like have a closed circle and then they'll try to put an open circle around it and then it looks like a bullseye. Okay, so you cannot do that. Okay, so no targets allowed. All right, so we're going to go ahead and graph our function. So yes, yep, so it'll only be closed is what you'll see. So at 0, 4, 1, 2, 3, 4, I have a closed circle. I have -1, 1, 2, 3. -2 is 2. Really, your slope is 1, so these points are going to continue. So that can help you graph your line. Okay, and see how it matches what I drew? It's going up from left to right for all the values where x is less than or equal to 0. Now we're going to have our quadratic. So this is open, so I am not putting an open circle around it. It's just staying closed. It's going to stay how it is. And then I have 1, 1, 2, 3 here. And then I have 2, 0 here. And that is closed. So when you connect these, do not connect them with a straight line. This is a quadratic. So you are drawing part of the parabola here. Okay, if this were to keep going on this side, this would be curved. Okay, it would make your U shape. And then at 2, 2, I have an open circle. And then 3, 1, 4, 0. So again, we are only making that key value noticeable. The rest are just little points on your graph. Okay, what questions do we have about piecewise functions? Do you remember doing some of those? Algebra 2, college algebra? The piecewise? All right, so in example 3, a family of functions is given. For parts A and B, we are going to graph all the members of the family in the viewing rectangle. Okay, this one does say draw a rough sketch, so we are just going to draw a sketch of that. And then in part C, we have to state the conclusion. Okay, so this is your equation here. Okay, so if you are doing this in your graphing calculator, if you were to plug in the values, okay, x minus 0 squared is just the same thing as x squared. If you plug in 1, you have x minus 1 squared, x minus 2 squared, and x minus 3 squared. And then you're going to do that in your viewing rectangle. Okay, so you can go to your y equals. The first one is x squared, x minus 1 squared, x minus 2 squared, x minus 3 squared, okay, I'm going to draw a rough sketch, and I'm going to set my window so it's -5 by 5, and then -10 by 10. Okay, so these calculators are cool because you can see the different colors here. So in my window, I had x squared, which had the vertex at 0. And then I could see every single time it moved further in what direction? To the right. All right, and then you guys can go ahead and do the same thing with B, and we're going to draw that one as well. And so for this one, you have the 0 value, but if you have -1, it's going to turn into plus. Sorry, sometimes I think my Chromebook is a touchscreen. Okay, and on decimals, you can actually do this a few different ways. So you could do x and then to the second power. That would be your x squared. I'm just going to change my window, -5 to 5, and -10 to 10. Okay, and then you could do y equals x plus 1 squared. You could do that. Okay, and then you could keep going, or you can also use sliders and decimals. You could do the c value squared, and then when you add the slider, you can see what happens to your graph. So here it's c is 1, and then you have 0, -1, -2, -3. Okay, so then you can see what happens if you move it left or right. Okay, so for part B, what happened with all of your graphs? Yeah. Okay, so then what we have to analyze is how does that C value affect the graph? So what did we notice about all the C values in part A? Yeah, they're all positive. And then in part B, they were all negative, right? And if they were positive, the graph moved in which direction? To the right. And if they were negative, they moved to the left. Wait, yeah, maybe 6. Okay, so how does the C value affect the graph? So you can say if the value is positive, the graph is going to shift further to the right. So I said this a few different ways. If C is positive, as the value increases, the graph shifts further right. If C is negative, as the value decreases, it shifts further left. Okay, so if it's positive, it's going to be shifting further right as it increases, and if it's negative, as the value decreases, it is going to shift further to your left. Okay, and then the last graph we're going to do today is a piecewise graph, but it's a special type of piecewise that is called a step function, because when we are done graphing it, it should look like little stairs. So the domestic postage rate of first-class letters weighing 3.5 ounces or less is 44 cents for the first ounce or less, plus 17 cents for each additional ounce. We have to express the postage P as a piecewise defined function of the weight of X with, and then this would be given to you in your story problem, with 0 is less than X, which is less than or equal to 3.5. And we are going to sketch the graph of this function. Okay, so the postage P. So we're going to start with P of X equals, okay, and what they tell you is that it is 44 cents for the first ounce or less. Okay, so we can use that to get started. So it would be 44 cents if, so it has to be less than 1, but remember with these real world problems, you also have to make sure it fits in a real world concept. They also tell you here that you're going to start with 0. So it's if 0 is less than X, which is less than or equal to 1. That's going to be the first ounce. And then it's 17 cents for each additional ounce. So in the next one, how are we going to find what our value is? It's 17 cents for each additional ounce or part of an ounce. How can I find my next statement? Yeah. We're gonna do it separately. So yes, we're gonna take that first value and add it to the 0.17. So the 17 cents for each additional ounce. For the next step, we're just gonna add those together. You can use your calculator for this. Use your calculator for this section. So it's gonna be 61 cents if it's between 1 and up to the next ounce of 2. And then you can keep continuing that pattern, right? So you can keep adding the 17 cents. So if we add 17 cents again, we get 78 cents. So that's going to go up to so it's for each ounce. So it's going to be up to 3. And then we're going to add 17 cents again. Again, you can use your calculator to do that. Now for this one, we're not going to do it up to 4 because they told you you are only going to be doing this for 3 ounces, 3.5 ounces or less. Okay, and they gave that to you here in that interval. So it's going to be 3 up to 3.5 or 3.5. And then our piecewise function has that special bracket there. Okay, so then we're going to graph this. And the more consistent you can make your tick marks, the nicer this will look. So I have 1, 2, 3, up to 4. And then let's think of a good scale for the P of X. So our X is our weight in ounces. Our P of X is going to be the cost in dollars. Okay, so I have 44 cents up to 95 cents. So I would just go by intervals of 20 cents. You can decide if you want to go by 10. So 20, 40, 60, $1. Okay, so when you are graphing this, the 44 cents, you're just going to estimate. So halfway would be 50, so about halfway there would be 44. That's an open circle. And then for any of those values of weight, it's going to be that flat rate of 44 cents. Okay, so it's constant. Okay, and then for 61 cents from 1 to 2, I'm going to put an open circle here. And then at 2, I'm going to have a closed circle. And then 78 cents is 2 to 3. So that's going to be close to 80. So we're estimating here. See how they look like little stairs that you can climb? Boop, boop, boop. And then the last one, remember, is only half of a step. So you have 95 cents. And then 3.5. So visually, you should be able to see that it looks halfway. All right. And then I'm going to give you the rest of the time to work on your homework. I have graph paper for you. If you need a piece, you will need that for your piecewise functions.